Hey, welcome to this 5-minute lesson on the introduction to compression. All the resources can be found in the description below to everything for this session. So, a quick little knowledge review. I want you to look at this flowchart. I want you to answer these questions. So let's pause the video and give it a go. Okay, so the first question, A and B will loop, so it would be 7 and 7 would end the loop. What type of loop? This is a while loop because we don't know, it's indefinite, we don't know when it's going to end. And the variables could be A, B, or T from the flowchart, so they're the key bits of information. So really we're going to look at compression today, and there's a little diagram here for you which is quite interesting. You can pause the video and have a look at it, about how much actual data and content is created in 1 minute of every day. And this is obviously from 2017, so you can imagine this has been increased again from there. So it's really important, and encryption is really an important part of this idea of data creation, because all of this is creating more data. Similarly, this sort of slide here shows us some of the key stats in terms of data in a day, really large numbers. And a lot of this wouldn't be possible without encryption, because everything that we post online, every picture we take, every video we watch, all of that is data which is stored somewhere online. So you can imagine the 4 petabytes of data up here, it's quite a large file. So really compression is the process of making something smaller. So we're taking the file and reducing the size. Now, part of the reason to do that, especially online, is to reduce transmission speed, so it works faster to send files across the internet. And obviously without compression, things like digital TVs, movie streaming, all of that wouldn't work effectively. So there's 2 types of compression which we need to look at, and that's lossy and lossless. So the first type is lossless. So this is where no data is lost during the compression. So this is really useful for things like text files, where there's lots of repetition. And one software we can use for that is run length encoding, RLE. And this reduces repeated strings, items of patterns. So this is one method of doing that. Okay, so this is a example of how we could use run length encoding. So this is a picture of an 8x8 Space Invader, and you can see each colour should be represented by 1s and 0s, but what we're going to do is illustrate them as letters. So W for white, R for red, and B for black. So the code originally, because it's 8x8, would be W, 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 black, black, W, W, W. Now what we do is we can perform our RLE version, which would be called 3W, 2 black, 3W. So you can see here, this is now 6 bits long, instead of being 8. So we've actually lost 2 bits, so we're actually reducing the file size. So the next one here is 2 to WW, 4 blacks, WW. So then it would be 2W, 4 black, 2W. You can see it becomes 6. And this is repeated all the way through to get our encoding. So you can see what it does. It actually reduces the size of our image, because we are taking away this idea of repeated patterns, and that's what run length encoding is all about. The next type of compression is called lossy compression. This involves removing unnecessary data to reduce the file size, such as things like sounds that humans can't hear, colours that humans can't see. So information which you wouldn't notice whilst watching a video or listening to the audio file or looking at the image. And this is really useful for bitmap images, audio files and videos. However, not useful to text files, because ultimately if we take something away using lossy compression, it can never be recovered. So then a text file would be unreadable. So lossy compression on bitmap images, you can see here. So JPEG is a form of lossy compression. And you can see from the bottom picture here, in terms of the quality, in terms of how it's reduced, and also the amount of data which is saved per compression, depending on how the quality you are. The same with audio files. WAV, MP3 are forms of lossy compression, and obviously what they're doing is taking away the sounds that the ears can't hear. and information which you just can't process. And you can see from the chart the actual amount of data that it's saving, and that's the whole process of compression. Okay, so what you should be doing now is having a go at this revision sheet. So have a go at the revision sheet and the questions and see how we get on. So pause the video, give it a go. Okay, so we're back now. I'm just going to go through the answers for you. So these are the answers from the revision sheet. So you can mark your own work, and then the table here as well to see how we produce that using the RLE. There's a set of useful links that you can use to do a bit of additional reading around the subject area. Again, these are in the description below. And here's an exam question. So I'm going to pause the video. I'd like to attempt this exam question, and we'll go through the answers. Okay, so we're back now. So explain why RLE may not be a good choice for encoding a text file. Sometimes RLE is not particularly efficient because there's not enough patterns for it to repeat, and actually RLE could increase the size of a file because there's not enough repetition of characters. So that's why sometimes it's not a good choice for a text file because there's just not enough variation in the file. Explain why data loss is acceptable in using lossy compression. This is down to the fact that we're removing unnecessary data which humans can't hear or see, and so we wouldn't notice it once we've compressed it. But obviously with lossy compression you can't get that data back. This last question here, so this would be, you've got 3, so it would be 3B, 1R, 4G, 2R. And you get a mark for each. 3B, 1R would be 1 mark, 4G, 2R will be the second mark. Okay, last question for today. Can you order these units within the computer system in order? So pause the video, give it a try, and this should be the results. So largest is zettabyte, zettabyte, going all the way down to a single bit. So it's close this way around. Okay. Thanks for watching, and goodbye.